We can get started. Great. Hi, everyone, and welcome to our workshop today. I have the pleasure of kicking us off. As Agueda said, I'm Jen Tom. I am the Senior Director of Experience Insights and Data Science at Code for America. Next slide, please. So just to give a little overview about Code for America is a civic tech nonprofit with over 15 years of experience of partnering with governments at the state and local level to be able to improve benefits delivery through human-centered technology. And we do that in the goal of reducing poverty and advancing equity. Next slide, please. So we work across three main program areas. The tax benefit space, where we provide low to moderate income filers with cash assistance through tax credits. We also work in the safety net space, where we help to improve benefit delivery for programs in food, healthcare, and childcare. And we also work in the criminal justice area, focusing on automatic records clearance. And you'll be hearing a little more about our work in that area in a bit from Chris Correa. Next slide. So we've used machine learning and AI for the past few years to improve service delivery.
We lost her.
And that's today's topic as well. And we'll provide some examples of how we've been exploring that and have used that in a case study. We see AI as a tool in our overall toolbox, and we're really cautiously optimistic about the application of AI to help improve benefits delivery. Next slide, please. So we've recently launched our AI studio at Code for America with the support of our generous funders, Google.org and JPMC Foundation. And our goal is to partner with government stakeholders to build a foundation to enable responsible experimentation and adoption of AI through shared infrastructure, prototypes, and pilots. And Mike is going to give you a preview of what that looks like later on in this presentation. Next slide, please. So we've identified a number of use cases that we've seen through our scan of the landscape, including what we've learned from our existing partnerships. And so these improve things like improving accessibility, deploying conversational interfaces to help folks navigate complex processes, helping people to understand dense policy landscapes, and general automation to help streamline workflows. Today, we'll be focusing on the use case of data matching and data deduplication, including one extremely useful technique called entity resolution. And we'll turn it over to Jeff now to give an overview of what that means.
Hey, Jen, thank you. Next chart. My name is Jeff Jonas. I'm the founder and CEO of Sensing. We have created an AI that does this thing called entity resolution. It's an SDK that stands for a software developer kit. It's for people who build software. Let's just jump to the next chart there, Mike. I'll quickly introduce what is entity resolution. Our definition is recognizing when records are the same person or entity, despite when having been described differently. Look how different those two records look, but there's enough evidence there you'd say those are the same people. Next. But conversely, recognizing even though records look the same or are close, but they're actually different. And here, this third record, it's almost exactly the same as the second record, the Robert Smith Jr. There's just one letter off, but man, that one letter matters. Next. And so entity resolution is about recognizing when things are the same or not, and then understanding how they're related. Next. So just a quick journey about how did we get here. My team and I have been building entity resolution technologies for years. It really dates back to building software for Las Vegas, a system called NORA, Non-Obvious Relationship Awareness. Casinos want to make sure they don't have professional card counters like the MIT card count team you may have read about in Bringing Down the Book or Bringing Down the House or the movie 21. They're also trying to make sure regulated entities that are sanctioned parties, mobsters, aren't at the casinos either. So that was kind of an early gen. We took a round of venture capital from the parent LexisNexis. We sold our 5th generation entity resolution to IBM. While at IBM, the team and I started a project codenamed G2. We wanted to start over a 6th time. Entity resolution's hard. We said we needed 50 million, and we started. In 2012, we started shipping it. In 22, we got a very unique opportunity to spin the team and the intellectual property and the code out. And so today at Sensing, we've created a commercially available entity resolution SDK. It's affordable, it's accurate, and it's really easy to use. Next chart. So just real quickly, I'll show you how it works, and then I'll hand it over back to Code for America. Next chart. So we're a library, like you would add a spell check library or a math library into a project. Sensing is an entity resolution library. Next. And what does that mean? What people pass into a Sensing library is names and addresses of phones of people or companies or vessels. And what comes out are things that are the same that it's seen, or things that are probably the same, but you should double check, and things that are related. On the input side, it could be adding new records, where it's building a little repository, an index of who's who, or it could just be a search. Next. And because it's a product for engineers, it uses something called JSON. Input is literally looks like the record there on the left, and the output is the thing on the right. Next. And so programmers take this Sensing SDK and with a few lines of code, push these JSON messages through, and the output is really high quality who's who. Next chart. On the left side, people put in historical data, it could be real-time or batch. And on the outside, people downstream put it into data warehouses or knowledge graphs or other indexes or visualization systems or do downstream decisioning. So we just fit in the middle. We're a transmission, not a car. Next. And people who are building us in, there's just a few different function calls, adds and deletes and searches. And most organizations can build this in with just as a few as 10 calls to the Sensing product. Next. And so it's got pre-built in smarts. Next. It understands the culture of names. It knows it detects it's an Arabic name, so bin and Hajj aren't part of the name. So it would score a name like this, hi. Next. Yet this name it would recognize culturally with the one letter different is very different. Next. And multiple scripts. Next. Another example of a multiple script, and then we'll just go to addresses. Next. And here, these two addresses look very different to a human eye, but in fact, those are the same addresses. Next. Yet these two addresses are so close, but there's one number off. These are just different addresses. And really being able to detect and build relationships in a graph helps you understand who's connected to who. And my last chart, and I'll hand it over, is here, is ultimately at the end of the day, if you're trying to know who you're doing business with, there's a difference between data that is connected on the left without entity resolution. And once you've entity resolved data, this visualization isn't ours, it's other technology that's used to visualize entity resolved data. But data that's entity resolved, you get data like that on the right. Not only are you determining which of those nodes are the same people, so you can deliver better services or avoid, I'll say, risk or fraud, but you're also understanding who's related to who to help make better decisions. Okay, with that, next chart. Our purpose is just make this easy, and we get baked into other people's work, and Code for America is going to show you some very exciting things that they have done.
Thanks, Jeff. That was a great overview of what entity resolution is and how it works. And I'm here just to walk through one use case where we supported the Utah Administrative Office of the Courts. So as Jeff mentioned, entity resolution is a way to identify and link records that correspond to the same real-world entity. We can go back to the previous slide. And that might include like a person across disparate data sources. And in the government context, any resolution might be a critical tool to reduce friction in service delivery and really scale eligibility determination processes that require data that might be spread across different agencies, or maybe even within a single agency across different systems or databases that have been developed over time. So why was this technology necessary in Utah? Well, in 2019, the governor of Utah signed HB 431 into law. This was a clean slate law, and this made Utah the second state in the nation to enact a clean slate law. This law directed the courts to identify and automatically expunge minor criminal records for qualifying individuals who remained conviction-free for a set period of time. So this policy and similar policies in now a dozen other states is grounded in the notion that making record clearance a routine government-driven service is the most effective way to remove collateral consequences and barriers that individuals and families face as a result of a criminal conviction. But these policies are only effective when they're implementable. And implementing this law in Utah was no small feat. So Utah's courts were directed to examine millions of case records spanning multiple judicial districts to determine whether each individual's record qualified for expungement. And that meant they needed to construct a complete history for every defendant in their system, verifying there's no other open cases, no new convictions had appeared, and that the individual did not exceed a lifetime limit on the total number of allowable convictions. And this information was coming from 37 district courts, over 100 county and municipal courts. And the case summaries for all these courts were stored in a couple centralized statewide databases, but there was no unique identifier associated with each individual person. So if an individual has 3 cases in 3 different courts, it's likely that information was entered in 3 different ways. And of course, we know also people's information might change over time. Names change, addresses change. So the courts were really challenged to determine eligibility. They had no easy way of constructing a person-level history. So we'll share some specific examples of exactly how complicated this data can be and examine whether or not entity resolution techniques ultimately succeeded in combining records from nearly 150 different courts in Utah. But first, just want to briefly review at a high level how this technology works and what some of the problems this technology needs to solve for. And we can go to the next slide here. So first, we were looking for a flexible solution that can match on multiple data points as available. In this particular case, every record was associated with a name, most had a date of birth and address, and there was a lot of other helpful information that was sometimes available. We needed to handle common data entry errors, and not just errors, but natural variations that occur. As Jeff mentioned, there are a lot of different ways to format an address. And we needed intelligent name matching. The Sensing solution leverages IBM's global name management database to match names in a way that's robust to transliteration, nicknames, and other variations that we were seeing in this data set. And then finally, as new records are added, we need to reevaluate records and update, merge, create new entity records as appropriate. And so at a high level, what does the end result of this process look like? We can go to the next slide. At the end of an entity resolution process with the resolved records, you can think about this as a mapping of each old or original record to a single new assigned entity ID. So in practice, this behaves a lot like a lookup table, an index that tells you which real-world entity each record belongs to, even if that original record initially had some inconsistent or overlapping information. So here, on the left side, we can see 12 different records that are similar in different ways, each with their own ID and differences in data. And on the right side is a representation of these newly created entity records, which actually accurately link the original record to a single new ID that represents a real-world person. So an eligibility determination solution can leverage these new IDs to create a complete picture of an individual's history. And in the case of Utah courts, this is the ID that could be linked back to cases and determine whether or not an individual met the qualifications for record clearance in that state. So again, Utah had millions of records coming from nearly 150 different courts. Most of these records lacked a reliable unique identifier associated with the person involved in the case. And so could entity resolution work here? Could we actually link those records in order to enable eligibility determination? We can go to the next slide. Code for America partnered with the Utah Administrative Office of the Courts and deployed Sensing's entity resolution solution to sort through decades of these court records. And initially in the raw data, we found slightly over 3 million records associated with criminal cases in Utah. But after entity resolution, we found those records corresponded to actually about 1.2 million people. So in other words, each real world person had on average about 2 or 3 different records in the court system. In practice, this isn't a normal distribution. Most people had just 1 case. But of course, there are a handful of people who might have had hundreds of cases or charges. So notably, it would have taken a small team of court staff several decades to manually review and link these millions of records. But we were able to resolve these records over a few days, quickly identified a few million duplicate records. So this was really encouraging from a time savings perspective, but were the results accurate? So the next slide. In order to figure this out, we actually, before fully implementing, the courts and Code for America partnered with the University of Utah to conduct a validation study. So we randomly selected about 1,500 of these cases that were automatically classified as eligible or not based on the entity resolution results. And a small team of expungement experts also reviewed these same cases and made their own determination. And whenever the automatic solution and the experts disagreed, another expert would carefully review the results and determine who was correct. And in this test, in fact, the experts did find one error with the automatic solution that was related to entity resolution. But next slide. So we can see that the automated solution based on entity resolution was not perfect during this early test, but it was very close. It was 99.9% accurate. And importantly, the experts who closely reviewed the different judgments found that the human experts were much more prone to errors. So we found it's much more likely for a person, even a person with domain knowledge and skills here, to make an occasional mistake in kind of manually searching through and linking records than it is for the state-of-the-art entity resolution solution here. So let's take a look at some real examples from the Utah data, and I'll share a disclaimer up front. We're going to show you data that closely resemble the real data that we were working with, but details on the names, addresses, and dates have been changed to protect the identity of justice-impacted folks. The next slide here. Could entity resolution solution handle name variations in this context? Well, this is one individual with over 50 names and 600 charges. And you can see here that he's associated with 2 different first names, 2 last names, and many different misspellings and permutations of orderings on all those names over a lifetime of involvement in the courts. And so this is one example. It's a little extreme, but we were able to automatically link all these associated records and resolve into a single entity. And note that if we were just relying on like an exact match or even some simple fuzzy matching across these different names, we would have missed some of these cases. It's possible we would have accidentally sealed a record that should not have been sealed. So we found that this was a pretty effective solution in handling all these different name variations that we were seeing. And next slide. Could entity resolution handle address variations? So Sensing uses an open source library that's explicitly designed for this purpose, uses natural language processing and machine learning models to accurately parse and normalize addresses. And this is an example of 6 variations on a single address that was associated with one person in Utah. So again, trying to match these records based on an exact match or some string distance algorithm wouldn't have worked in this case. But if you have address data, and that's part of your strategy for linking records, a good entity resolution solution can handle these kinds of variations out of the box. And then finally, on the next slide, just want to acknowledge numbers and dates are often incorrectly heard or read or spoken or typed. And in Utah, when identifiers like a social security number or driver license number were available, we ended up matching a lot of records where the identifiers were not exact matches. And often on the next slide, we can see these data challenges are co-occurring. So this is one example where the first record features a unique date of birth in February relative to the other 2 records. And then there's also a subtle difference. The third records include a surname of Johnston, while the other 2 records are Johnson. And this is an example where like a really simple rule-based exact string matching solution is likely to fail to link all 3 of these records. But a probabilistic entity resolution solution that is trained on these common variations was capable of successfully deduplicating and associating these 3 different records with a single person. So these are 3 different records, again, that all look a little different, but actually represent the same person. Next slide. We did find that modern entity resolution solutions can be used to address government record linkage needs where data quality is challenging. And in this particular case, we were able to link decades of case-based court records to create unique individual histories that unblocked implementation for this kind of government-initiated, more automated way to deliver relief in Utah. And next slide, I have a few takeaways. Here, just as a review, like, want to take a moment to reflect on what the Utah courts were able to achieve. They delivered meaningful relief for thousands of residents who no longer had to navigate a costly and burdensome petition-based process to seal their records. And they found a way to do that while sparing court staff the overwhelming task of manually reviewing millions of these records. And perhaps most impressively, the solution was not only faster, but more accurate than a traditional manual review. And so as technologists, this is a reminder of what's possible when we really thoughtfully apply innovative technology to public sector challenges. It's not just about efficiency, it's about creating new possibilities. finding ways to eliminate administrative burdens, finding new paths to deliver real-world impacts that might not otherwise be possible without emerging technology. Thank you for your attention. I hope this inspires you to explore how similar opportunities might exist to solve pressing problems for the folks that you all are serving.
Great. Thanks, Chris. I appreciate it. At this point, we're gonna go into a little bit of a demo, and I'm gonna kind of share some of the things that we're trying to achieve in the AI studio. So bear with me just a second while I move to another tab here, and hopefully you can all see this okay. So one of the slides Jen had showed earlier around AI Studio was a list of different use cases that we've seen for AI out in the government sector. And so here today, we'll focus on entity resolution as a potential use case. And I'll share a little bit of the way we're approaching working with government to evaluate different use cases, in this case, entity resolution. And so Chris gave some great examples of how this applies in the criminal justice space, particularly as it relates to automating the clearance of criminal records. But there are many other places in government, social safety net services, and just various places in government agencies where you're going to see this sort of recurring challenge of duplicate individuals in records and systems. So one of the things that we find to be helpful when we first work with states and localities on different solutions is to try to get in early and prototype and try to get a sense of the data we're working with. So I'll just jump right into this little entity resolution prototype that we have. The idea here is for us to get a sense of, based on some of the challenges you have with your data, would entity resolution be a good fit for solving some of your issues? So we start with just a basic CSV file that is going to have some standard person level information. And I'll just upload an example here and get a small preview. So the typical things you might find: name, date of birth, email, social security number. Just here as an example for us to play with. But one of the things that we often struggle with in early engagements with states is, okay, access to the data sometimes takes a little while, right? Getting a data sharing agreement, being able to work through that with folks. How can we show and create a scenario where we can actually prototype whether or not entity resolution would work well for a state in an early phase before we have access to their data? So one of the things that we played around with here is the idea of using synthetic data. And in this case, we're going to take this initial set of records we have here and generate some duplication, anywhere from 4 to 10 records per person. And we can set some variability in the data itself, or dig down a little deeper if we want to get into some specific metrics that we might already know about our data set. We might know that the records in our systems we have almost about 100% data completeness when it comes to having a first name and a last name for folks. And the data quality might be fine on that level. We might find that for something like date of birth, maybe we only have that 70% of the time, and the data quality there is 40%. But then for something like social security number, we might not have it very often, but when we do have it, the quality might be better. The idea is to just create some basic parameters where we could generate some synthetic data that we could then use to test out entity resolution and to see what sort of bang for your buck you might get from being able to do a solution like this. So here we've generated a bunch of duplicate records. We have emulated a lot of the sort of clerical type errors that you might find, in numeric data entry. This isn't going to catch everything. It's not going to catch necessarily the person who has had a surname change or moved addresses, but it'll give a general idea of what is possible with entity resolution. So for the next step, we'll go over to this matching records step. And here again, we are relying on Sensing's product for entity resolution to match records and identify potential duplicates. And what's interesting, I think also interesting about, there's a little dashboard here that shows, you know, we had 51 records. We have an average of 6.7 records per person. Here's some statistics around the data completeness, and also some stats on the matching. And one of the things I'll say about Sensing is it's really hardwired for accuracy. It's really is built against having false positives. And if you and so one of the things that you'll find in using software like this is you don't just get matches, but you'll get potential matches. You'll get a match score. And here I could just do a quick kind of drill down into, you know, individual records and which ones. I won't get into every individual case here, but there may be cases where you have a potential match or a match, and you actually can even drill down into why. Why did this match? What were the specific fields that that made this match? And then from there, you could take this data, you could just use this as a general idea or rule of thumb for what might be possible for entity resolution with your agency, or you could download these matches. You could use this with a small subset of your data as well in order to just kind of test this out and see if it's something that might work well. And with that, I think I'm going to hand it back over to Jeff, who has some really interesting new advancements over on their side in terms of data. Let me just share.
You know, as you were just commenting, it's difficult at times for organizations to pull the data together. You got to go find the custodian, the owner of the data, and ask to use some data, and then you're trying to make synthetic data, which can get you down the road a little ways. But one of the things that we've just recently released is called a cord. It's a collection of relatable data. I thought, well, I would share that with everybody here. Let's go before that, though. Let's go to chart. Yeah, that chart there is, if you're trying to test what is entity resolution going to do for you, traditionally it has, let's say, these 8 steps. Now, the first 4, give me a screen build. The first 4 of these, do a click for me there, Mike. The first 4 is you're trying to get representative data in hand. Does it have the cultural diversity of the names? Does it represent the kinds of addresses that you want to use? Is it, anyway, all that kind of stuff for being representative. Then you got to clean it up. Then you got to prepare it so you can put it into your entity resolution. Then you got to get some hardware. Maybe you had a big pile of data and you have to subset it. All of those first 4 steps is about just getting ready to do the entity resolution. And that can take some time. That can hold projects up 3 months. Give me a screen build. The last 4 items, traditionally, and this is what we really have broken through and changed with our purpose-built AI for entity resolution, is typically you have to configure your algorithms, you have to set weights, you have to create some rules, you run it, you look at the results, and then you rinse and repeat until you go, well, that's got to be good enough. And so that's the 5 through 8 is really about the entity resolution tech. And we've largely solved that and made it accessible now really to everybody, not just the elite. But what about 1 to 4? And are you going to create synthetic data, or are you going to wait to bring the stakeholders together? So go to the next chart there. A cord is a collection of relatable data. If you just Google Sensing cord, you'll find this. This is data you can download and use. Now, by relatable, it contains overlapping features. So it's combinable. These would contain things like names and addresses and phone numbers. This is all primarily business data, but PPP loans over 150,000. This cord is of Las Vegas. Click London, it's over there in the UK. Click Moscow, it's in Cyrillic with various data sets. But PPP loans, Department of Labor compliance actions for organizations that have had bad labor practices, not paying overtime, and so on. That's publicly available data. We've added it to this cord so you, data scientists and whoever, can just download this data. So it's overlapping features around a shared domain. Our cords are all just historical snapshots, but it's real data. The idea is you can combine this data to see something representative, what would happen for you, and then you could quickly add your own data by putting it into a CSV template or into JSON, and it allows you to do not only experiments quickly around entity resolution, but also it puts you on a path of creating assets that you will be reusable if you're taking a system to production. Go to the next chart. We have a little free desktop eval tool. You could just download it. You'll find it under Sensing Eval Tool. This is one of the screens. Those data sets in the chord I just showed you, just drag them over onto the canvas and give me a screen build and push load. And you're just getting entity resolution in one click without any more work. And by the way, if you create some of your own data, you could just drag it onto here and map it and do the same. Next chart, in our little eval tool, this is out of the Moscow chord. It matched these two records by just running that data. You could do this yourself, by the way. This is literally 5 or 10 minutes of work for you to do to try this yourself. But just looking at those addresses, it's now you're talking about malformed addresses and across languages, which is why we have spent $50 million on this SDK. And next chart, there's more products showing up out there that have sensing inside. This product called WinPeer, they have a data quality and cleansing product that runs on a desktop. Not only can you drag any of these data sets I just showed you in a sensing chord into here and give me a screen build there, Mike. And again, it's entity resolution one click, but it's a product. It's not like our little eval tool. This great product allows you to go out and pick pointed files that you have on your drive, CSV files, XML files, JSON files, this file, that file, connect to a database. And it allows you to help you just map it into the sensing JSON. And then again, one-click entity resolution. Yeah, and so with that, maybe these sensing chords, we've been using these a long time to do proof of concepts with folks in days, but we've released all these data sets. We can make custom data sets for you just for fun, just ask. They're pretty easy, and it may help you fast track your project. Okay, great. That's all I got. Thanks, Mike.
Thanks. So we have opportunity for you to ask questions about anything that you've seen in some of the earlier slides and with the case studies, and also with some of the functionality that Sensing has and Jeff has previewed. Next slide, please. We've also are interested in hearing from you. And if you are thinking about using entity resolution or considering using entity resolution, we'd love to hear more about sort of what you're thinking about and what your use cases are. And if there are any questions that you might have in terms of technical implementation, since there are some of the world's best experts of entity resolution on this call right now, please feel free to start sort of putting your questions into chat. As you're starting to think about questions, we have a few questions that we'd like to sort of discuss